precipitation strengthening or edge hardening process of aluminum and copper. It is the precipitation hardening or edge hardening. It is the main purpose to improve the non-ferrous material physical properties. Improve the physical properties of non-ferrous materials. In this precipitation hardening or edge hardening process is applied to the copper, aluminum, nickel, magnesium and titanium alloys also. It is for aluminum copper alloy, aluminum tin alloy, aluminum magnesium alloy also. His main objective is to produce the fine precipitate particles. Okay, to produce the fine precipitate particles in the material. Okay, that precipitate particles to improve the physical properties of the entire material. So it is the new phase of forming. Okay, this create the new phase of forming. Okay, is the general precipitation edge hardening process. So mainly used for non-ferrous material physical, improve the non-ferrous material physical properties. Okay, so for applied to the aluminum copper alloy, aluminum tin, aluminum silicon alloys material. Okay, it is the precipitation strengthening or edge hardening process. So this involves the three steps mainly in this application. The aluminum copper alloy for aluminum 4% and copper is 96%. So duro aluminum. So this application is duro aluminum precipitation strengthening or edge hardening process. Is the first step is to heating the process. Okay, this is the first step is to heat the material. Okay, is the first step. Okay, heat the material to above the solvent temperature. Okay, so heat the material is first stage. Heat the material to the above the solvent temperature. So solvent temperature is around 500 to 550 degrees Celsius. Okay, heat the, this is the first stage. Heat the material to 500 to 550 degrees Celsius. Okay, then second process is quenching. Okay, is the first one stage is heating material to the solvent medium, then quenching to the second one. Okay, then quenching to the second process is the quenching. Is the quenching process is a rapid quenching process is a rapid cooling process. So at that process the alpha phases of the material is converted to the super saturated solid solution. Okay, is a homogeneous solution. Alpha is a homogeneous mixer. So heat the material up to the homogeneous mixer, then convert. Next process is quenching. So alpha phases is convert to the alpha SSS process. It's a super saturated solid solution. This solid solution is not stable for room temperature. Okay, this is not stable for room temperature. Then this after the second stage, the third one is aging process. So maintain that material to the aging temperature. The supersaturated solid solution is converted to the alpha and theta phases. Okay, this is the aging temperature. The fine particles of CuAl2 obtained. This Cl(A2) is a fine particle. CuAl2 is a fine particle. This fine particle is improve the hardness of the material. Is a totally three stages. One is solid solution, quenching and aging process. Okay, so first is alpha stages, alpha SS. Third one is alpha and theta phases. Okay, this is a precipitation strengthening or edge hardening process. So in this process aluminum and copper alloy of aluminum 4% and the copper is 96% of. So this is called duroalumin. Is a first step heating process. They heat the material above the solvent temperature to get the homogeneous solid solution of alpha phases. Okay, alpha. So alpha aluminum is 4%, copper is 96%. This is duroalumin. Maintain the temperatures around 500 to 550 degrees Celsius for heating the material. The step 2 is the quenching process. Is the quenching is a rapid cooling process. So after rapid cooling, the alpha phases convert to, okay, no sufficient time of Cu to form fine particles. Okay, is a rapid cooling. Then formation of new structure. Okay, so that is called supersaturated solid solution phases. That is alpha SS. It is not stable for in room temperature. Okay, then after the aging temperature, this supersaturated solid solution alpha SS is converted to the alpha plus theta. This is the theta means CuAl2. these fine particles, okay, these fine particles you able to increase the hardness of the met alloy, okay, hardness of the aluminum copper alloy of copper alloy, so particularly for aluminum and copper alloy, so that is called duralumin, okay. After the age hardening process, the fine particles is improve the hardness, yield strength and ductility of the ductility properties, okay, mainly increase the physical and mechanical properties in the aluminum and copper alloy process, okay. So totally three process steps involving. So one is the heating process, so quenching process and aging process, the three steps, 1, 2 and 3 steps. Heat the material so above the solvent temperature, below the melting temperature, okay, is around 500 to 550 degrees Celsius, okay, around 500 to 550 degrees Celsius. Then quenching is the rapid cooling, okay, is the rapid cooling. So this aging process, okay, in this 550 degrees Celsius is alpha phases, is the rapid cooling is the alpha as a supersaturated solid solution phases. After the aging process, alpha S is converted to the alpha and theta phases, okay, alpha and theta phases, okay. The theta phases is precipitation particles, that precipitate particles improve the hardening of the material. This is the three stages, okay, in the precipitation or age hardening process. Thank you.